talk about the laws of geologic dating. How do we know the ages of rocks and other objects and events? So if we take a look at this model, this is the one that's in the classroom. It's got 4 colors of sand and it's got sticks, and the sticks all count as one event. So if we look at this model, which events came first, second, third, fourth, and fifth? So just in you have a note packet there, hopefully, and how do you know which layer came first? This would be a good point to pause. And now that you've come back, what we're going to do is just kind of reverse this, and hopefully you can see that the blue sand came first, and you know this because it's on the bottom. You know the yellow sand came next because it is above that. You know, the purple sand came next because it's above the yellow. The red sand came last because it's on the top. And the sticks came last because they disturb all those layers. And so these are the basis of how we know what we know about the ages of events in geology. So looking at your notes there, the first thing we want to think about is what direction do all the layers go? And we can see that all of these layers go in this direction. That's a horizontal direction. That's called the law of original horizontality. And what that is sedimentary layers of rock are deposited in a horizontal direction. The exception to the rule is if you put something on a hill, sometimes you can get layers to go in vertically. The other piece of that information, though, is that if think of like a piece of paper, as you turn the page of your notes, which comes first, the paper or the fold? Well, the paper comes first, not the fold. The fold comes second. And so when layers are folded, the fold is always younger than the layer itself. And that's also original horizontality, the idea that you have to have a layer before you can do something to it. Then, secondly, if we think about it, we knew which layer came first based on which one, was on the bottom, hiccup. And so that the one that's on the bottom is called the law of superposition. So the layer on top of another layer is younger unless imagine that piece of paper that's folded again. If you had the layer of paper and then the writing on top, the writing had to come second. If I fold that paper in half, the writing is now sandwiched in between those 2 layers of paper. So that puts the younger layer in the middle and the older layer is on the outside. So if you have a severe fold, that may not be true. Or if you picture a boulder rolling down a mountainside, that may also not be true, because as the boulder rolls down the mountainside, that younger layer may end up on top. But that law of superposition says that this older layer is going to be on the bottom. And then if we think about these layers here, and we look specifically at this purple layer here in the middle, do all of the layers reach the edge? And some of you may answer yes, because they have to reach the edge of the glass, because otherwise you'd have a big old pile of sand there. If you look at this purple one, it touches the glass on this near side, but if we were to swing around over here, it doesn't. And so you could say no. That's called the law of lateral continuity. Layers will continue until they reach an edge or boundary. And so in this case, the purple's actually using the yellow as the edge, but then it runs out. That's also lateral continuity. So layers will stop only when they reach edges or when they run out. So they are continuous across the entire surface when you see those layers. So in your writing it says layers will continue until they reach an edge or as they run out as the materials that form them ran out. So if we, that's called the law of lateral continuity. Those of you football fans, lateral is a sideways pass. Lateral continuity means to continue sideways. And then finally, which came first, the sticks or the layers? We can tell that the layers came first because it drags all these colors down. So it pulls the red down into the purple down into the yellow, and the yellow down into the blue. And so that's called the law of cross-cutting relationships. Anything that cuts across, so the stick, anything else, these layers, is younger. So the stick had to come last in order to disturb all these layers. Here is the first example of how we're going to use those laws. So first thing you're going to do is you're going to get this, you're going to get a picture or an image of a cutout. Here's a river, so you can imagine something like the Platte or the Elkhorn River here. And so you'd be this tiny little dot like somewhere on the edge here. So these are huge areas. You always want to look around your outside edges, make sure there's usually information out there, and look for any text boxes like what we have here. One thing to keep in mind in geology is geology builds from the bottom up. So we're used to starting at the top left and reading to the right and then down. Notice how when we look here, we're going to start at the bottom where it says oldest, and we're going to work our way up. So whenever we start a geology problem like this, we're going to start at the bottom. So the first event we're looking for is the oldest layer, or what happened first. And so if we look at our image here, we can see that there's two possibilities, E or B. The thing though that I can see is there's little chunks and bits here. And if I look right here and right here, I can tell that B is below. So B is going to be my oldest event, and that's going to be the law of superposition. Okay, and then if I look, these little bits and chunks, that's that erosion surface H. So H is going to come next, and I'm going to use two different laws. You could use original horizontality, because you have to have a layer before you can do something to it, or you could use cross-cutting because it cuts across layer B. Either one of those would be acceptable answers. Next would come layer E, the slate, and that's because of superposition. It's on top of layer B. It also works though for lateral continuity. It uses layer B as an edge. So you might get a test question that says, what two laws tell you that E is younger than B? Well, it's superposition and lateral continuity. It used B as an edge. The next layer that's going to happen is going to be layer G. And G is by cross-cutting. Because it cuts through both layers B, H, and E. But it gets eroded by I. So I is going to be our next event. And so I, again, it could be original horizontality. Or it could be cross-cutting. So you could use either one, whichever one works best in your brain. After I comes A, by superposition, it's on top. Move our camera up a little bit here. Okay, and after A comes D by superposition. Notice how we're using superposition a lot. That's going to be your bread and butter. It's going to be the one that you're going to go to a lot. After D comes C by cross-cutting. After C comes J, again by original horizontality or cross-cutting. And then finally comes F by superposition. Okay, so there is your final order. And at this time, I would encourage you to pause your movie and do the next page by yourself before you look at my explanation. Okay, and then this one is another pretty big one. You'll notice that underneath here we have a text box that we need to pay attention to. So the text box has lots of information in there, and we'll be referring back to that. A couple of things to keep in mind. 4 starts down here at this corner and finishes way up here at the top. And 7 is labeled as an intrusive igneous rock. So if we think about what an intrusive person does, is they are, like the butt-in ski interruptus kind of person. So that is a Buttinsky interruptus kind of rock. So we need to keep that in mind as we go through this. All right, so the oldest event, I look, and there's several numbers down here at the bottom. I could choose 7, I could choose 9, I could choose 3, I could choose 8, I could choose 4. But it looks like 4 and 8 are both cross-cut, so I know those come later. If I think about an intrusive person, they butt in, it's going to butt in to what? Well, it butts in, they interrupt what? Well, it's going to interrupt all the way up to here. So I know 7's not the first number. So then it's going to be like 9 or 3. And if I look down here at my text box, what I see is 9 is metamorphic rock and 3 is folding. Well, the rock has to be there first, so it's going to be 9 by superposition. It's on the bottom. And I'm going to use SP for superposition. Then 3 comes next by original horizontality. You have to have the layer before you can have the folds. Now 7 still goes up into whatever these layers are, so I'm going to look at 5 and 6. 5 is the sedimentary rock and 6 is the folding. So then 5 would come next by superposition. And then after that is going to be 6, again by original horizontality. Okay. Now, if I look, I can actually get layer 7 by cross-cutting because it cuts through 5 and 6 as well as all the others. After that, let's see, number 10 seems to be the next number up, and that's listed as an erosional surface. So I'd say 10 next by cross-cutting or original horizontality because it erodes 7. And then what happens next? Well, I have layer 1 here by superposition. It's on top of 10. And now what? I have 2, 8, and 4 left to deal with. 2 is the surface erosion of the cliff top. So, and it looks like these are all nice and flat along that cliff top, so I know 2 is going to go last. But now which came first, 8 or 4? So if I look at A is one big long piece, but 4 starts up here and it's kind of chunked up. So 4 has to come first, and then it gets cut by 8, and then everything gets eroded by 2. So 4 comes next by cross-cutting because it cuts through layer 1. 8 is next by cross-cutting because it cuts number 4, event number 4. And then 2 is original horizontality. It erodes both 8 and 4. So those are your sample problems. Make sure you ask if you have questions. Thank you.